In this video, we'll take a look at what are arrays. So an array is basically a data structure that stores a group of similar elements in contiguous blocks of memory. For example, over here we can see there are 8 spots available, indexed from 0 to 7. So arrays are zero index. They begin from 0 and go up till n minus 1. That'll be the last index. So coming back to what arrays contain. So let's say this array can only contain, um, you know, just numbers. So we can do 1, 5, 7, 9, 11, 13, 21, uh, negative 15. So this array contains elements of only type integer. And we can have another array which can contain elements of only of type string. So we can have hi, bye, John, and so on. Basically, we can have all the strings in these empty spots within the array. Another thing to take note about arrays is basically that they're of fixed size. Fixed size, which means there is, if we want to suppose insert 16 into this array, unless this is a dynamic array, which we'll take a look at later, we cannot insert 16 into this array or any other integer for that matter. And so yeah, that's basically what arrays are. And usually in programming languages such as Java and Python, arrays are stored within the heap memory. And for those who are not aware of what is heap, we have this main memory within our computer, which is called as RAM. So RAM or main memory. And this consists of there are many parts to the main memory, but we will only be focusing on two main parts. One is the stack, and the other one is the heap. So the way elements or like the way items are stored within the stack memory is basically in the form of LIFO, which is last in, first out. So this is where the call stack comes into picture, which we will take a look at later when we look at recursion. But usually the reference variables are in the stack. So reference variables are in the stack. And in the heap, there are objects such as arrays, linked lists, any data structures, objects and data structures are in the heap for languages such as Python and Java, but they for other programming languages it might be different. So in Java and Python, we will have the arrays stored in the heap, and consecutive blocks of memory within the heap will be allocated for the array. So suppose we call this array as array1, arr1, then the reference variable will be within the stack, and it will be pointing to a location within the heap that will have 7 consecutive locations freed up so that we could store these numbers. So this is how it would approximately look within the memory. So by pointer, I mean this reference variable will contain the location of this array which is in the heap. So since this is the heap, uh, in the heap memory, everything is in random order. So there is no particular order. For example, in stack, as I mentioned, it's last in, first out. But within the heap, the objects are only identified using addresses. So this particular array would have a starting address of some hexadecimal value, but to keep things simple, I'm going to represent it as just a decimal value. So let's say the address was 100. Then this ARR1, which is a reference variable, will contain this address 100, which I am referring to using the pointer. So like by this arrow, this arrow just represents the fact that ARR1 contains the address to the array which is in the heap. So some of the important things to note about arrays is that random access of elements within the array takes constant time. The reason is when you know the address of a particular element, the computer knows it. So for example, let's say we have ARR1 of 4, then the computer quickly computes the original address, which is 100, the address of the first element, and then it adds whatever the size of the data type is. So for example, the size of data type integer is 4 bytes. So it would be like this. So the address is going from 100 to 104. So this whole location from 100 to 104 would be reserved for number 1, and so on. So once we get to 111, it will be 108, 112, 116. So the address of 100, of the element 11 would be 116. So the computer quickly computes the address and gets the value 11. So that's the reason it takes constant time for random access. Now we will take a look at insertion, deletion in the next video. Thank you all for listening.